back, students, to the fifth session of Basic to Advanced Java series, where you and me are going to learn, code, and execute Java problems together. So, our problem of the day is to find whether a number is prime or not. So, students, what exactly is a prime number? I'll tell you. Prime number is a number which is only divisible by the number 1 and the number itself, which means it is not divisible by any other number in the whole integer system. Okay, so for example, 2, 3, 5, 7, no, 9 is not a prime number because 9 is divisible by, completely divisible by 3. Okay, 11, 13 and 17 and so on. So students, we'll create a logic where the logic will find whether a number is prime number or not. Okay students, for that we have to create a public class. Let us name our public class as prime. Now we have to create the entry point of our class, public static void main. Now students, let us consider our number to be 11. Okay, now we have to create a flag, a boolean flag. Boolean is prime, and let us set this boolean flag as true. Okay students, now we have to create a for loop where the for loop will start at 2 because all the prime numbers are divisible by 1. So our for loop will start with the number 2 and it will go until num minus 1 because all the prime numbers are divisible by itself. Okay, and we have to increment our loop. So students, now we have to create a small divisibility test for our number, and for that we'll be using a for loop, for if loop. Okay, if loop inside a for loop. At each iterations we'll be checking in the if loop that if a number is completely divisible by our iteration number or not. And what do you mean by completely divisible? Which means the number will be divided by an iteration number, and if it gives if it is divided and it gives no remainder, which it means that it is divisible, and if it is divisible then it means that it is not a primary number. So what we'll do, if this condition is true, we'll set our boolean as false, and after this, as we have got that our number is not a prime number, we'll come out of the loop by using break statement. Okay, now after that we simply have to print out what our boolean is. If this conditions comes true, then the boolean will be automatically placed as false. If not, then the boolean will be remain true. Okay students, let us check. A minor mistake students, we have to initialize that our I is a integer, and also I have written the P as small letter. In Java we have to be careful with all these capital letters and etc. Now we should run our code. It is true, which means our number is a prime number. Let us check for another number 12. False. Why? Because number 12 is divisible by 3, 4, 6 and 2 itself. Now let us check for a number 17. True. So students, now I'll tell you a different logic. Here we have used the number, the iteration should go from number 2 till the number num minus 1, which is here is 16, and this creates our time complexity even larger. Now for that, what we can do is we can use a concept called math.sqrt in Java, it is used for square rooting a number. Now why are we taking the square root of a number as the last range of a iteration? I'll tell you. Let us consider a number as 11, and see, it's still true. I'll tell you why. The square root of a number 11 is 3.3, and there is a concept that any non-prime number will gives the factor of non-prime, that it is a non-prime, lower or equal to than the square root of that number, which means if our number is 11, the square root of 11 is 3.3. At the let us consider the iterations 2 and 3, as we cannot take the iteration 2.3. At the second or the third iteration, it will give the factors that it is prime number or not. Let us check. Is 11 completely divisible by 2? No. Is 11 completely divisible by 3? No. So, but we can check this as, let us take a number 4. Let us run. As we all know that 4 is a non-prime number, but the logic behind taking the square root of that number is, what is the square root of number 4? It is 2. What is the starting iteration? It is 2. So at the second, like, it will go from 2, it will end at 2. Only one iteration. In only one iteration, it will come to know that this is a non-primary number. How come? 4 is 4 completely divisible by 2? Yes. And you can use this logic for all the prime numbers. So the time complexity will be reduced to many, not many, but way lesser than half of the time complexity used before. Okay students, this is our desired output. So students, keep learning, keep practicing. Signing off.